Hello. So we've talked about the relational data model briefly in the last section. And so what we're going to do in this part of the course is talk more about the relational data model, which is the model that Oracle follows. And we're going to be learning about in this course. And we're going to actually learn how to create our own tables in this part of the course. So there's a lot of topics that we're going to talk about. So each one of the topics that we're talking about, these are individual videos that you can watch if there's any concept that doesn't make sense to you. And then here are a couple of links to the SQL commands, examples on how to use them if you have difficulty with any of the commands. Now, there is some terminology that we need to be aware of when we're talking about a relational data model. So there is a couple of definitions that we're going to talk about. So when we talk about the relational data model, we are basically talking about the collection of interrelated relations or tables. So a relation is basically a table. So when we say relation, we're talking about a table. Sometimes it could be referred to as a file. And basically what a database is, it is a bunch of tables. That's what a database is. It's a bunch of tables, each table representing certain data, like a student, and like we said an entity before. But basically a database is a bunch of tables. And when we talk about tables, another name for a table is a relation. So when you hear the word relation, we are just talking about a table. Now, what does this table or relation contain? Well, it contains a bunch of records. It contains a bunch of rows. So every row in this table is considered a record, like a student record, a customer record, a product record. So when we talk about a row, we're talking, it's the same as record, another name for it is tuple. So a table is a relation, or a relation is just a table, and a row is called a record. Now, each one of these records contains information. And so it has columns. Every row has a bunch of columns in it. And so a column is just called a field or an attribute. So we are storing tables. Each table has a bunch of columns or attributes or fields that we need to collect about each record or row. And when we talk about the degree of a table, it's basically the number of attributes or columns. So if I ask you, what is the degree of a certain table, like the table in front of us here, what's the degree of this relationship? All you have to do is count that it has 1, 2, 3 columns, and you'll tell me, oh, the degree of this relation is 3. So degree is just how many attributes do we need to store about this row. And finally, SQL. SQL just stands for Structured Query Language. It is basically the database language. This is the programming language that we use in database world. Now, columns, like we said, are known as fields or attributes. So we call a column an attribute or a field, and each column is going to store a piece of information. So it's going to store like someone's name, someone's social security number, the department that someone works in. Each of these columns has to have a data type. So when you're constructing the tables and you are deciding about each column, you're going to have to decide each column what the name of the column is and what the type of the data that the column is going to store is. And so if you think about, if you think back to high school, or maybe earlier in college when you took algebra, there was something called the domain and something called the range. I don't know if you remember back these terminologies, but basically the domain is the set of valid values that can be stored in a column. So when I say, for example, what is the domain of the social security number? Well, it's basically what are the valid values that I can put in the social security number column. And one of the things about relational databases is that every single value I put in a cell or in a column entry has to be atomic. Okay, atomic means that you cannot break it down. So if you think of an atom as something that you cannot break down, this is what we mean. And so atomic values means they are indivisible. So if I think of your name, if you think of your column, a column as a name, well, if your name, is Donald Duck, Donald Duck can be broken down. It can be divisible. It can be broken down into Donald as the first name and Duck as the last name. So in that case, we can think of it as non-atomic. It's not really atomic. So when we want to store information in columns, we want to store them in a way that they are atomic so that we cannot really divide them more. So some values, let's look more talk more about domain. If I have a column that's the marital status of someone, well, what are the possible options for marital status? Well, someone can be single, or they can be married, or they can be divorced. Maybe we can add widowed to the list. But basically, we have a set of values, and those are the only ones that we say are possible values. So think of a domain kind of like as a drop-down option sometimes that you can choose from. If I am putting like the birth date of someone and I break it up into columns like the month, day, and year, well, the month has a domain that it has to be January, February, March, all the way through December. If I think of the domain for the first name, for example, well, the first name has to be a bunch of characters, and it doesn't contain numbers, for example. If I think of a salary, well, it has to be a floating point number, a decimal number that's greater than 0. And maybe if I'm in a company, I can say, well, the salary can not be more than $200,000, but I know that at least it has to be greater than 0. So when we're creating these columns, we need to know the column name, we need to know the type of the data that we're going to store in the column, and we need to know the possible values, the valid values that we're going to store. And we call that the domain. Now, what are the possible data types that we can use in Oracle? So there is a bunch of data types. We are not going to be really using all of them. But basically, if you want to store a string, you want to store a bunch of characters, there is char and there is varchar2. Now, varchar2 is specific to Oracle, and this is the one that we are going to be using because this is the one that is most common. And what you do is you say varchar2, and in parentheses, you say how many letters you are going to be storing in the string. So how many letters are possible, or how many characters are you going to be allowing this string to contain? So that's one data type, a bunch of characters, a string basically. The next type of data types are numbers, and there are a bunch of numbers. If you just want to store a single value like true or false, kind of like a Boolean, if you think of C++ and Java, if you think of a Boolean, that would be stored as a bit. So if you just want to say yes or no, like did they pass the class, were they absent that day, that would just be stored as a bit. In addition, you can have number, and number takes two numbers as input. The first one is the precision, and the second one is the scale. So if I say that a number has 5 digits of precision, that means the number has 5 digits. If I say it has, if I say comma 2, the scale is 2, that means I'm allowing it to have 2 digits after the decimal. So a number that has 5 comma 2, the maximum for it would be 999 and 0.99. Okay. So when you're thinking about money, for example, if you're storing money like someone's salary, you would use a number. The comma would be 2 after the comma, and then you think of how many possible digits can this number contain. You can also use numeric 5 comma 2 or decimal 5 comma 2. So all these three have the same meaning. If you want to store a whole number with no decimals, you can just use integer or int. If you want to store a smaller number, like kind of like a short in Java, if you're talking about Java, this would be like a short that goes up to about 32,000. That's called small int. And if you want to choose a really small number between 0 and 255, this one doesn't support negative numbers. It's called a tiny int. And also there is date. Okay, so the most common ones that we're going to be using are varchar, int, and number. Okay. And we're going to, of course, be using dates also. Now let's talk about tables. When I need to create a table, what do I need to make sure about this table? Well, the first thing is that I need to make sure I choose a unique table name. So every table has to have a distinct name. I can't have two tables called student. Okay? If I say select something from student, it's not going to know which table do you mean. Do you want the first table or the second table? So when you're choosing a name for your table, you need to make sure you choose unique names. Now, within a table, after I choose a unique name for my table, I need to make sure my column names also are unique. I can't have two columns called first name. You know, which one is really the first name? You can't. So table names must be unique. Column names also must be unique. Each row needs to be distinct in some way. We cannot have duplicate rows. And the way we make sure that these rows are distinct and unique is that we make sure that we have a column that is the primary key and has a way to uniquely identify that row. Like we talked about before, if you have a student, maybe the banner ID column is the way to uniquely identify that student. You can't have two students or two rows that have the same banner ID. You can't have two cars in your car table that have the same VIN number. When we are inserting data into the columns, we need to make sure that whatever we're inserting is atomic. Like we saw before in the object-oriented data model, which we're not using, we said one of the advantages of that model was that it allowed columns that were not atomic. So we saw where we can have a student, for example, that's registered for two classes, and we have a column that has these two classes. We can't do that with the relational data model. Every column value has to be atomic, so we cannot have multi-valued attributes. The order of the columns is insignificant. So if I store my information, first name, last name, date of birth, or I say last name, first name, date of birth, it doesn't matter, because when you're inserting the data, you're going to tell it each column where you're putting the information in. So order of columns doesn't matter. The order of the rows doesn't matter. Now, when we're representing our data, our schema, we saw before the entity relational diagram. So what we're using is the entity relationship data model. So this data model is used to model the databases because it's easy to use. What does it call for? Well, all the ER data model calls for is that you have entities, which we call tables or relations, that have data, and you are going to specify the relationships that exist between these two tables. So if you think about data models that we've talked about, we talked about the external view, we talked about conceptual view, logical view, and then physical view, or sorry, data models. So this is basically the conceptual view. What are the entities that you are storing information about? What are the real world objects that you are storing information about? And what are the relationships that exist between them? For example, you have a student and you have a course. A student, a specific student, student A, is an entity, and the database course is an entity, and there is a relationship that exists between them. Student A is enrolled in the database. So you have two objects, a student object, a course object, and the relationship between the student and the course is the re-enrollment. Now, what we're going to do is we are going to learn how to create those tables in this class. So here I'm looking at the sample database that we've been using, and I'm just looking at two of the tables that are in there. Our table here is called the department. So this table is representing a department entity. What are the columns that this table is storing? It's storing the department ID, it's storing the department name. What type of data is department ID? Well, it's a number that has up to 5 digits. So up to 99,999, that would be the maximum department ID. Department name is a string and it can have a maximum of 100 characters. For now, we don't really need to know what this, the syntax here, but here I see the word primary key, and I just want to point out primary key means the way I uniquely identify a row in this table. So the way I uniquely identify a row in the department table is by department ID. So when we're inserting data, that we need to make sure that every department has a unique department ID. Here we have a table called employee. Employee is the table name. It is the entity. It is the relation. It has a bunch of columns. Each column has a data type. And then again, the primary key, the unique way of identifying an employee is by employee ID. And then foreign key we'll talk about later. Okay, we also had customer table, and we had a product table, and then we had the customer order table. So those were the 5 tables that existed in that SQL file that we ran at the beginning of the semester.